Hello and welcome back. Today we're going to learn about classes and objects, important topics if you're interested with object-oriented programming. Classes in general uh, are used to represent generally real-world classes. For example, if you have any real-world entity, something like let's say bird, then bird can be a class, and then there can be different types of birds like a pigeon is a bird, a crow is a bird, right? So we could think pigeon and crow as instance of the bird. you know Both pigeon and crow family, they can have certain common attributes like they can have feather, they fly, these kind of things are common, but there are certain things that are different. So and then that's pretty much how even the object-oriented simulation, if I can call that, works. So when I say simulation, I mean modeling. Basically, we look into real-world problems, and then we try to represent those real-world objects, classes, everything using programming language features. Because after all, computer is used to solve real-world problems. So that's how the languages are developed, computers are developed. The direction of the languages, computer itself, everything is governed by what we need. And what we need is we um, live in certain environments, we interact with environments, and we need to improve our lives. So while doing so, we need a bunch of tools, and then computers, programming languages. These are certain tools that help us to improve our lives. So that's a very general kind of introduction. Now, without wasting time further, let's uh, let's just dive into the coding. I think that's the most important thing, because we have the main focus of this all this video lesson is to actually provide laboratory sessions, so that you are very hands-on, because that's what is tested, and that's what is needed when we go for software engineering related jobs. Okay, now let's actually uh, uh, create a class, create an object, and then use that class and that object, and do something. So for that, I have chosen a simple something that's familiar to everyone, which is like a something that's learned in very early on, is a elementary school or middle school, high school. Of course, we learn about that in college also. Let's first create uh, the file. Okay, vi. I'll just call it my app. Okay, my app dot Scala. Okay, I'm there. So what we are going to do is we're going to create a circle class. Okay, because this video is mainly about class and also object. An object we have already seen multiple times, but we're going to still use it so that we have idea how classes and objects they can be put together, and then the whole thing forms the forms an application. So first, we're going to create a circle class. So in Scala, how do we define class? We start with the keyword class, or more accurately, reserved word. In Scala, we use the word reserved word because a lot of these words can be redefined as opposed to other programming languages like C, C++, Java, etc. So class and then class name, class it is circle. Okay, and pretty much like object, we have this opening brace and then the closing brace. Now we need some attributes, like we were talking about. If you have a bird, it has feather, it flies, this kind of things. So similarly, if you have a circle, circles attributes are, circle is generally defined by it can be defined by radius, right? So We just need a variable. Okay, yeah. So earlier we saw something called val. So val, and then a, if I do a is equal to 0 or something, that's a constant. But here, I need something that I can change because I'll have to set values somewhere from my application. Okay, if it's not making sense now, please just hold on to it. When we complete the application, it will make a lot better sense. So I need something that that I can change. Basically, it's not be fixed because I need to set the value. So I'm going to, for that, what we have in Scala is var, val and var. Var is something, it's a variable, comes from variable. Val comes from value, like a constant. In mathematics, if it's a constant, it doesn't change, right? Um, in math, variable we use like x1, x2, x3, those kind of things. A lot of things in maths are constant because you can never reassign value to the same identifier in mathematics. That would be inaccurate. But in computer, we do that because mathematics is more on a paper and then also in mind. So we have, while paper is not infinite, but our brain can think a lot. So we need that kind of freedom. So that's why we have that's kind of non reassignment associated with um, variables, and then the names and then the values. Let's call that way. In computer, we have finite memory and we have finite processing power. So we'll have to make use of that and then do the computation that we need. And sometimes we also try to represent something which is close to infinite in real world life with this finite, um, you know, computing power in terms of memory and processing power. So there, I'm going to say radius is equal to, I'm just initializing it, and then I'm going to create another variable called area because I need a placeholder where I can assign value once I compute it. So I'm going to put 0 dot 0. So if I assign this way, Scala automatically does a type inference, and then the type of the area would be um, like a float because I have a decimal there. That's how it knows. Okay, and then for the radius, since I have only integer value like 0, it doesn't have 0 0.0, so its type inference is going to be integer. Okay, so now I need a method, okay, to actually do the computation, compute area. And since I don't plan to pass any parameter, I can leave that empty. I also don't plan to return anything, so it's going to be unit, and I always need these two braces, okay, opening and closing, which basically anything written in between these two braces is the body of the method. Okay, so what is the formula for area of a circle that we learned somewhere in the in the middle school or high school? So just recall that is basically pi, the 3.1416, that number in mathematics, multiplied by the square of the radius. So in Scala we have a class called math, or more accurately probably we could say object, and if you're not sure you can always go here and look that Scala math dot 2 pi, and it should bring something. Okay, there's a math, and this is basically um, uh, okay, that means also deprecated, but for now we'll just try this one. So you can see a bunch of methods here, and then it's a place in the Scala hierarchy of classes. So and then if you do not know something and if you want to learn a little bit more, you can just read it. It says the object math contains methods for performing basic numeric operations such as elementary, exponential, logarithm, square root, trigonometry function, etc. So I was not sure. I was not sure about whether it was a class or it was an object. Um, Normally, if you, there's another similar language called Scala, and Scala, this math would be a class basically. So sometimes I myself get confused. Okay, so if there is such kind of situation, basically it's a good idea to actually go to the documentation and just read the documentation quickly. We didn't spend too much time. We just get necessary information. Otherwise, there's a whole lot of thing that we might be using later, so we don't have to really worry about that. So I'm going to close it. Now let's just write area. I can reassign because it's a variable, and then this is how I address that. That's what we show in the documentation, multiplied by, and there is another method, the method power, and how it works is if I need the square of a particular variable, then I write variable first and then the power. Okay, the square is power 2. Okay, that's it. That's it. So my circle class is basically done. Now I need my class is done, but this class I cannot just run it. There is no way for me to actually instantiate and run without making use of object. Like in some other programming language, I could have another method called main method, and then I could, especially in Java, actually that's what I was trying to hint. I could have main method inside this class, and then I could just run it. Even though that may not look very readable because main is not a part of the circle's description, right? So now here, whatever I have in this class, circle is pretty much is related. Almost everything, actually everything in this class is related to circle. Like circle has a radius, circle has area, and then I have a method that does computation that calculates the circle's area, right? So there is nothing else related. Everything is about the circle class, about the circle, the real world object circle. Okay, so that's how it should be modeled actually, whenever it's possible. If you are doing object-oriented programming. So now I need the application. So my application will be this one. Okay, I need, because in Scala, if I want to instantiate something and a class basically, and then run it, I need object. So object, and then I can name anything. I can say circle app. I guess now I'm going to create the application that I can run, and I can make use of my circle class, because that's the purpose of this session. All right, so we know how to do this main method. We have done multiple times before, so nothing new here. Unit, I don't have anything to return, is equal to over here, right? Now we have a few things. Now I need to actually instantiate that class, because that's how once I instantiate, I'll have access to the variables, because we need to think about runtime. When you're running something, we think about object. Like we talked about bird, and then we talked about crows, and then we talked about like something like pigeon or so, right? So a bird is a common like abstraction. Like when I say bird, I'm not like very specific, like what kind of bird, which bird it is. So bird is more like a conceptual kind of thing. You can think of a bird in that way. And then when you talk about crow, and that's the very specific thing. Okay, so you might again say which crow. There could be many crows, right? You might say which one, right? So still there is a way to identify them, right? But still it came down to a specific species of bird, right? And a very specific item. So similarly, we in computer, if you want to have access to the memory, we need to have access to the memory because we're going to store the attribute. So that's done primarily using object. So for that, I'm going to create the instance of the circle class, because that's what I'm going to use for computation in my application. So, and I use val because when you use val is a constant. But there's one thing that to keep in mind. Even though my circle object is val, I can I can change the field inside it. I'm not able to reassign the pointer whole thing, but I can change the value inside it. Right? I can change radius, I can change area, but I may not be able to reassign it. Okay, but I don't plan to reassign. If you plan to reassign, then you do val. I don't have planned here because it's a small program, so I'm making it val. And also, it's a very good practice to program using val actually. That'll come later in part 2 or even more advanced Scala programming. Actually, in distributed computing. So that's actually that's the reason why Scala has the concept of var and val. Many people think this is Scala is more advanced form of Java programming language, and Java doesn't have this kind of things. And many other languages like C, C++, Pascal, those languages also don't have this concept, like a val and var. Even though there is something like constant is there, and then variable is there, but these are not identified using the reserved words like this, because Scala has a particular reason. It'll be easy if you represent this way. It'll be easy actually to do the transformation for in order to make the program multi is thread service called. There is a concept. Okay, we probably will not go into detail of that now because it might be a lot. So we'll just keep it there for later. So now val, and I just give it a name. It could be any name, but I try to give a meaningful name. That circle object is equal to new. This is how I create a circle object. I don't have any parameters, so I don't need a bracket. I don't need it. I can just omit it. Okay. So next is I need to set the radius because I need to supply the radius, right? So how do I do that? Circle obj dot. This is how I can actually refer to the field. So Scala, we don't have to necessarily have a method. Actually, the method will be created and supplied during compilation. So it's more like a implicit kind of thing. If I have a field there, compiler automatically understands it needs to create something called a getter setter kind of method. But I don't have to necessarily use in my program. I can just write object name dot the field name, the field from the class, right? Is equal to, I just give some values. I'm going to give 2 easy, radius 2 because it's going to be square. It's going to be 4, and then we're going to multiply that with 3.1416, etc. So that we can verify quickly without using any calculator. So next is I need to actually run that method there, in circle object, circle object, okay, compute area, okay, I need to run that method. If I invoke this way, is that's going to be executed, right? So main, remember this main method is the one that actually runs. So I can see program, at least for this application, it runs sequentially because I don't have anything here that asks that prompts computer to do like a parallel computation. So but just by writing class, it doesn't execute, like it doesn't run. So even though we have method here compute area, it needs to be called from somewhere or runnable, more like a main method. Then only it will be invoked. And where does it get value? Because I already set value. So this object, this is more like a instance of this. Obviously, it's an instance, strictly instance. Here we are seeing a static code, but when it in computer when it runs, when you create the object, it'll have these fields, all these fields in the class that we are seeing, and it'll assign a memory location and provide this field. So whenever I say circle object, then it will have radius, it will have area, that memory allocated, and then if I do circle of obj dot radius is equal to 2, then in that memory location it will set 2. And when I circle object dot compute area, it's going to look for whatever is needed. For example, math.py comes automatically from library, math.power, that's also library. Radius is going to look for radius, so and it will find that in that memory location, right? And then it will do whatever this function asks you to do. You know, the procedure is defined in the implementation of this function or method, you could call it, because Scala is a object functional programming language. So once the computation is done, we can just print it, right? I'll just say area and now how do I get that area? It is circle. Again, everything is referred with dot area because that's the memory allocated. Once it's computed, it's going to be stored in that memory location, which was assigned for the variable area, and that is done right here in this line of code, right? All computation is done and assigned to area, and I have invoked that right here. Okay, whenever object is created, these two memory locations are reserved and values are initialized to whatever I have given here. Okay, our program is pretty much done. I'm going to save it and I'm going to quit it and I'm going to compile it. My app Scala. Okay, it's compiled. Interesting. And what's the name of the application? Let's see that. Circle app is my application right here. Okay, that's what I'm going to run. Circle. If everything, if the program does not have a bug in it, we are going to see area as 3 point right here 3.1416 multiplied by, well, that there are more numbers after the decimal, multiplied by radius square, okay, which is 4. So 4 multiplied by 3 point something is going to be 12 point something, right? So that's going to be our answer, and that's exactly what we are seeing, 12 point some values along many numbers there. So if you're interested, you can do the computation, but that certainly looks right. Okay, so this one basically completes this particular session. I will see you in the next session.